How to design AI agents that are helpful and scalable while still staying aligned with responsible AI and the organization's business rules? Hi, and welcome. I'm Georgia, lead technical trainer at Microsoft. And in this video, we'll cover Microsoft's responsible AI principles, Copilot customization in Dynamics 365. We'll explore task agents, autonomous agents, prompt and response agents, and selecting the right Foundry tools for different requirements. Let's get started. By the end of this video, you'll be able to apply responsible AI principles to your agent designs, configure business terms, and customize Copilot in Dynamics 365. Design custom connectors that integrate AI agents with Dynamics 365 Contact Center, and build task-focused and autonomous agents using Copilot Studio. These are practical hands-on capabilities that map directly to real-world business scenarios. Let's start with the foundation that everything else builds upon: Microsoft's Responsible AI Guidelines. Before we configure a single setting or build any agent, we need to understand the principles that should guide every decision we make. Responsible AI is not just a concept, it is a practice. Architects must ensure AI systems are safe, trustworthy, and aligned with organizational values. This applies whether you are building a simple chatbot or a complex multi-agent system. The key takeaway? These principles are for everyone involved, from product teams and data scientists to business leaders. As an architect, you set the tone. If you prioritize responsible AI, your entire team follows suit. Let's walk through the 6 responsible AI principles. Fairness means treating all people equitably and avoiding harmful biases and outcomes. Reliability and safety require your AI to operate consistently under all conditions with proper monitoring and safeguards. Privacy and security demand strict protection of personal data and compliance with regulations. Inclusiveness ensures your AI empowers everyone without creating barriers. Transparency means helping users understand how the system works and how it reaches its conclusions. And accountability reminds us that people, not machines, bear responsibility for AI outcomes. Organizations must implement guardrails, governance structures, and human oversight to uphold this responsibility. Responsible AI spans the entire solution lifecycle, not just deployment. During design, identify risks early. During development, run fairness tests and security reviews. During deployment, ensure human oversight is built in. During operations, commit to continuous improvement. As an agentic AI architect, your best practice is to create a responsible AI checklist for each phase and make it a required part of every project milestone. Now that we have a strong, responsible AI foundation, let's shift to something very practical: business terms in Copilot for Dynamics 365. This section focuses on how you define and configure the standardized vocabulary that Copilot relies on to generate accurate, relevant outputs in customer experience and service scenarios. Grounding is what makes AI outputs relevant and accurate. Business terms are a core part of that grounding layer. They ensure Copilot understands your products, processes, and terminology. Without them, Copilot is like a brilliant assistant who does not know your company. The best practice here is to treat business terms as a living dictionary. Keep it current, keep it comprehensive, and assign someone to own it. That is how you build AI that actually helps. Think of business terms as the voice of your organization inside AI. When Copilot generates summaries or recommendations, it references these terms: product names, service categories, department names, case classifications. They all matter. The best practice here is to collaborate with business stakeholders to define these terms. Do not let IT define them in isolation. The people who talk to customers every day know the language best. Enabling Copilot is straightforward, but prerequisites matter. Correct licensing, security roles, workspace environments, and data availability for grounding must all be in place first. Your best practice is to create a readiness checklist before any enablement. Verify its prerequisite with your admin team. Skipping this step is the fastest way to a failed deployment and is entirely preventable with proper planning. Field management is a critical architecture decision. You're essentially curating what information Copilot can see and use. Include the wrong fields and summaries become noisy. Exclude the right ones and you lose accuracy. Best practice, work with your business analysts to identify exactly which fields drive meaningful summaries. Then test the outputs. If Copilot references outdated terminology or irrelevant data, revisit your field selection immediately. Customizing conversation summaries lets you match Copilot's output to your organizational structure, terminology, tone, and compliance requirements. You have two main format options. Paragraph format produces a single narrative summary, ideal for quick reads when agents need a fast overview. Structured format organizes information into distinct sections, which is better suited for standardized processes and regulated industries, where you need clear categorization. Choosing the right format depends on how your agents work and what your compliance environment demands. Start by observing how your service teams currently consume information, then configure the format that best supports their existing workflows. Beyond formats, configuring specific business terms and standardizing language is important. Map key fields like issue type, product line, and service tier, so every summary uses consistent terminology. The best practice is to define a standard next steps vocabulary aligned with your SLAs. When handoffs happen between teams, consistent language prevents miscommunication. Small details like these are what separate a good Copilot deployment from a great one. Generating great AI insights is only half the battle. You also need to surface them where agents actually work. Custom case forms can embed Copilot summaries directly into the case record, so agents see relevant context without switching screens. Agent dashboards can display triage information, queue data, and supervision insights powered by AI. And role-specific service forms let you tailor what different tiers of agents see based on their responsibilities. The principle here is simple. Bring AI insights to the workflow, not the other way around. When you reduce context switching, you improve both agent efficiency and the overall customer experience. Let's look at the types of business term Copilot relies on. Each business term type, from product names to customer segments, plays a distinct role in helping Copilot produce relevant outputs. The best practice here is to audit your business terms quarterly. As your product catalog evolves and your service categories change, your AI vocabulary must keep pace. An outdated term library is one of the most common causes of AI output quality degradation. Understanding how business terms flow into Copilot is essential for good architecture. It starts with your Dataverse fields where your organizational data lives. These fields feed into Copilot's grounding layer, which is the mechanism that anchors AI-generated outputs to your actual enterprise data, rather than generic knowledge. When business terms are properly defined and mapped to the right Dataverse fields, Copilot can generate summaries, recommendations, and insights that are contextually accurate and organizationally relevant. Your role is to ensure this pipeline is clean and well-maintained. Any gaps or inconsistencies in business terms will surface inaccuracies in Copilot's outputs. Here are the best practices to keep your business terms effective over time as an agentic AI architect. Use consistent naming conventions across all departments to avoid confusion. Avoid abbreviations unless they are universally understood within your organization. Align your terminology with CRM fields so there's no disconnect between what agents see and what Copilot references. Review and update terms regularly because your business evolves and your AI vocabulary should too. Ensure your terms reflect actual customer language, not just internal jargon. And finally, establish clear ownership for maintaining terms. Someone needs to be accountable for keeping this vocabulary current. Without ownership, terms drift and Copilot's accuracy suffers. Building on what we just covered about business terms, let's now explore the broader customization options available for Copilot in Dynamics 365. There are 4 key areas where you can customize Copilot to fit your organization. Business terms and domain language define how Copilot understands your organization. Prompt and output customization shapes how it responds. Data scope controls what it accesses, and surface integration determines where it appears. The best practice is to prioritize these in order. Start with terms and data scope because they define the foundation. Then refine prompts and integration based on user feedback. Let's start with business terms and domain language customization. Domain language customization is where you teach Copilot to speak your specific organizational dialect. The best practice is to create a glossary document that captures every term Copilot should know, organized by department and region. Share it with stakeholders for validation before configuring. This collaborative approach ensures nothing gets missed and builds organizational buy-in from day one. Prompt and output customization is where you shape how Copilot actually generates its responses. This affects email drafts, case summaries, conversation summaries, customer recommendations, and actionable next steps. You can customize several elements. Tone lets you match your brand voice, whether that is formal, friendly, or somewhere in between. Structure controls how information is organized in the output. Required fields ensure critical data points always appear. And you can define sensitive terms to avoid, preventing Copilot from using language that could create compliance or customer experience issues. Think of prompt customization as coaching your AI to communicate exactly the way your organization needs. Data scope and field configuration determine what information Copilot draws from when generating outputs. You can configure case fields, CRM entities, knowledge article sources, contact and account fields, and interaction timeline elements. This is a critical architecture decision. The goal is to ensure Copilot uses information that is relevant, approved, and up to date. Including too much data creates noise and potentially surfaces sensitive information unnecessarily. Including too little leaves Copilot without the context it needs. Strike the right balance by working closely with your business stakeholders to identify which data sources are essential for each Copilot capability you're enabling. Surface integration determines where Copilot's outputs actually appear within Dynamics 365. You can embed AI Assistant in case forms, conversation windows, customer timelines, knowledge views, and agent dashboards. The principle here is meeting agents where they already work. When Copilot's outputs are integrated directly into existing workflows, agents do not have to break their rhythm to find AI-generated insights. They see relevant suggestions, summaries, and recommendations right in the context. This reduces friction, speeds up resolution times, and increases adoption. Always design surface integration around the agent's natural workflow rather than forcing agents to adapt to your integration design. This summary table connects each customization area to measurable business impacts. Think in terms of outcomes, not features. The best practice here is when you're presenting your Copilot design to stakeholders, always frame customizations as business outcomes. Do not say you configured prompt settings. Say you ensured consistent, brand-aligned communication. That is the language that gets executive buy-in and budget approval. This visual shows how the 4 customization layers create a pipeline that shapes Copilot outputs. Each layer depends on the ones before it. The best practice here is if AI outputs are inaccurate, troubleshoot from the bottom up. Start with business terms, then check data scope, then prompt settings, and finally surface integration. Most issues originate in the foundation layers, not the presentation layer. Here are best practices to guide your Copilot customizations. Start with agent workflows. Understand how your teams actually work before configuring anything. Keep business terms consistent across all touchpoints. Review Copilot outputs regularly to catch drift or inaccuracies. Limit the data scope for precision, because more data is not always better data. Update prompts as your business strategies evolve, since what worked 6 months ago may not fit today. And always enable human oversight so agents can flag or correct AI outputs. The point here is iteration. Your initial configuration is just the starting point. Plan for ongoing refinement from the very beginning. Now we are going to explore how to extend Copilot's capabilities in Dynamics 365 Sales through custom connectors. This is where things get particularly interesting for solution architects, because custom connectors let you bridge external data sources and APIs directly into the Copilot experience. Connectors as reusable building blocks, and that is exactly how we as architects should think about them. One well-designed connector can solve multiple Copilot actions across different scenarios. Best practice? Just design your connectors with reusability in mind from day one. Use generic, well-structured API definitions rather than building narrow, single-purpose connections. This multiplies the return on your integration investment significantly. Before you start building, there is an important environment requirement to understand. Your environment must have Dynamics 365 apps enabled, and this is a hard prerequisite. The best practice is to create a pre-development checklist that includes environment validation, API host configuration, and Open API definition review. Invest time in writing clean, well-documented API definitions. They tell Copilot exactly what data is available, and quality here directly impacts connector reliability. Security is paramount when connecting external systems to your Copilot environment. OAuth 2 with Microsoft Entra ID ensures proper authentication, and the 2-up registration pattern enforces least privilege access. The best practice is to never shortcut the security configuration. Document your app registrations, token flows, and permission scopes clearly. A properly secured connector protects both your organization and your customers. Security shortcuts always cost more later. Once your connector is built and secured, you need to publish its actions through Copilot Studio. The process involves creating a Copilot action that references your connector, configuring how data retrieval works, publishing the action, and then requesting admin enablement. Here is something important to plan for. Actions may take up to 7 days to appear after publishing. This is not a bug, it's part of the enablement process. Build this timeline into your project plan so stakeholders have realistic expectations. Good architects manage expectations as carefully as they manage architecture. Governance and compliance are essential considerations when designing custom connectors. Admins are responsible for ensuring connectors comply with organizational policies before they're enabled. When you connect to external data sources, be aware that third-party terms and conditions may apply, and those need to be reviewed. There's also an optional certification path that makes your connector available organization-wide with formal validation. As an agentic AI architect, work closely with your compliance and security teams during the design phase. Bringing governance into the conversation early prevents costly rework and ensures your connector is ready for enterprise deployment from the start. This image shows the end-to-end flow of a custom connector in action. Data originates from your external API, flows through the custom connector into Copilot Studio, where it is processed and made available as actions, and finally surfaces within Dynamics 365 Sales for your sellers to use. Understanding this flow is critical for troubleshooting and performance optimization. Each step in the chain introduces potential latency, security considerations, and failure points. You should design monitoring and error handling at each transition point. A well-instrumented connector pipeline gives you visibility into performance and helps you resolve issues quickly. In the next section, we're going to focus on designing AI agents that integrate with Dynamics 365 contact center channels. This is where everything we have discussed comes together. Dynamics 365 Contact Center is a unified, intelligent platform designed for customer engagement across multiple channels, including voice, chat, messaging, and digital channels. AI agents within this platform deliver fast, consistent responses while reducing the workload on human agents. They provide contextual insights that help agents resolve issues more effectively. The key word here is unified. An AI agent designed for contact center must understand and maintain context across all three channels, providing consistent assistance whether the customer calls, chats, or sends a message. Each contact center channel has specific AI capabilities. For voice, AI provides call summarization and real-time transcription, so agents can focus on the conversation rather than taking notes. Live chat benefits from suggested replies and knowledge article recommendations that speed up response times. Digital messaging channels use automated flows and sentiment detection to route and prioritize interactions intelligently. And the omnichannel widget provides embedded AI assistance that works across all channels. Make sure you design your AI agent to leverage the unique strengths of each channel while maintaining a consistent experience. The capabilities differ, but the quality standard should not. Designing agent context is one of the most important architectural decisions for contact center AI. Start by defining your entity types: customer, case, product, subscription, or whatever is relevant to your business. Then map the specific context fields to your agent needs, such as case ID, customer type, channel, and more. Here's a critical best practice. Only include the attributes your AI agent actually needs. More context is not always better. Unnecessary fields add noise, increase processing time, and can create privacy concerns. Designed for precision, a focused context model leads to faster, more accurate, and more privacy-compliant AI responses. Copilot features within Contact Center include conversation summaries, suggested actions, knowledge retrieval, customer insights drawn from CRM history, and automated drafting. These capabilities can significantly reduce handling times and improve resolution quality. An important configuration detail: you enable these features per environment and per user role. This gives you granular control over who sees what. Not every agent needs every feature. A frontline agent might benefit most from suggested replies, while a supervisor needs conversation summaries and customer insights. Design your feature enablement around role-based needs to maximize adoption and minimize information overload. When designing AI agents for contact center, keep these 4 design considerations in mind. First, ensure omnichannel awareness. Your agent must handle context transitions between voice, chat, and messaging seamlessly. Second, align with existing work streams. Your AI agents should complement established routing, queuing, and escalation processes, not disrupt them. Third, use guardrails. Define clear boundaries for what your AI agent can and cannot do autonomously. And fourth, maintain data security with least privileged access. Your agent should only access the minimum data required to perform its function. These 4 considerations will keep your contact center AI effective, secure, and trustworthy. This image traces the complete flow of an AI agent within contact center. It starts with a customer interaction, which generates channel signals like sentiment, intent, and channel type. Those signals feed into the agent context model, which assembles the relevant data. Copilot then processes this enriched context and generates insights, suggestions, and draft responses. Finally, the human agent retrieves this AI-powered assistant to deliver a faster, more informed response. Understanding this end-to-end flow helps you identify optimization opportunities and potential failure points, As we wrap up, remember that great contact center AI starts with thoughtful architecture at every stage of this pipeline. Now we are moving into one of the most practical sections of this module. We are going to talk about how to design task agents. So what exactly is a task agent? They are specialized AI agents for completing specific actions using Copilot Studio. They integrate business logic, APIs, and enterprise data into structured workflows. The best practice here is to resist the temptation to build one agent that does everything. Focus each task agent on a single, well-defined job. A narrow agent is easier to build, test, maintain, and troubleshoot than a broad one. Task agents use a modular architecture built from 5 core components. First, goals define what the agent needs to accomplish. Second, skills give the agent its capabilities, things like extraction, reasoning, and planning. Third, actions are the actual operations the agent performs through connectors, APIs, or workflows. Fourth, knowledge provides the structured and unstructured information the agent draws from. And fifth, context supplies data about the current interaction. Think of these as building blocks. Each one serves a distinct purpose, and together they create an agent that can reason, act, and deliver results within your business processes. When designing a task agent, always start with a clear business objective. Do not build the agent first and then configure what it should do. Start with the outcome you need. For example, you might want to automate order entry, summarize customer inquiries, trigger onboarding workflows, retrieve the inventory status, or create and assign work items. The best practice here is to use outcome-based goal statements. Instead of saying the agent should read emails, say the agent should extract order details from customer emails and create sales records. That clarity of purpose drives every design decision that follows. Let's dig deeper into goals. A goal is your agent's core mission, the single thing it exists to accomplish. Here are some well-crafted examples. Create a sales record from customer data. Submit a support ticket with priority levels. Generate a summary of a customer conversation. Notice the pattern? Each goal is actionable, meaning the agent can do something concrete. Each is observable, so you can see whether it happens. Each is also testable, so you can verify it works correctly. And each relates directly to a business outcome. If your goal does not meet all 4 of these criteria, refine it before you start building. Once your goal is defined, you need to assign the right skills. Think of skills as the core capabilities your agent brings to the table. There are 4 main types. Language understanding lets the agent extract intent and classify messages, so it knows what users are asking for. Data interpretation enables the agent to read, summarize, and transform information. Planning allows the agent to sequence multiple steps in the right order. And execution gives it the ability to actually invoke actions. Your job is to match the right combination of skills to your agent's goal. Not every agent needs every skill. Actions are where your task agent actually does work. Each action you add requires 4 things: input parameters that define what data goes in, an output schema that defines what comes back out, authentication to ensure secure access, and error handling for when things go wrong. You can create actions through several methods: Power Platform connectors for common services, custom connectors for proprietary systems, direct API calls, Dataverse operations for business data, and cloud flows for complex orchestrations. The important design principle here is to keep each action focused on a single operation. One action, one job. That makes testing and troubleshooting much simpler. Your task agent is only as good as the knowledge it can access. Common knowledge sources include SharePoint libraries, product manuals, standard operating procedures, Dataverse tables, and knowledge articles. But here's the critical part. Your knowledge must meet 4 criteria. It needs to be accurate, because wrong data leads to wrong decisions or actions. It needs to be recent, because outdated information causes errors. It needs to be governed, so you know who owns and maintains it. And it needs to be indexed, so the agent can actually find and retrieve it efficiently. Poor knowledge management is one of the fastest ways to undermine agent reliability. Safety rules are essential for keeping your agent predictable and trustworthy. These are explicit constraints that direct or limit what the agent can do. Here are some real examples. Never override a customer's credit limit. Always ask for confirmation before submitting an order. Escalate immediately if complaint keywords are detected. These rules act as guardrails. They ensure your agent behaves responsibly even in unexpected situations. Make sure you define these rules upfront, and this is part of your responsible AI obligation. Do not treat safety as an afterthought. Build it into the design from day one and document every rule clearly. This image shows how a task agent actually works end-to-end. It starts with user input, which flows into the agent's reasoning engine. The reasoning engine is where the magic happens. It evaluates the input against the agent's goal and decides what to do next. From there, the agent reaches out to three resources: actions to perform operations, knowledge to retrieve information, and context to understand the current situation. All of these feed back into the reasoning process to produce the final outputs. Understanding this flow is critical for designing agents that are both effective and predictable. Let's review with 6 best practices for task agent design. First, start with one high-value workflow. Do not try to automate everything at once. Second, keep goals small and focused. A narrow goal is easier to build, test, and maintain. Third, provide clean, structured data. Garbage in, garbage out applies here more than ever. Fourth, limit action permissions to the lowest scope necessary. Fifth, implement monitoring and logging so you can track what your agent is doing. And sixth, test with real scenarios and edge cases, not just the happy path. These practices will save you significant rework down the road. Now we are stepping into autonomous agents. If task agents are the workers who follow instructions, autonomous agents are the ones who can figure things out on their own. Autonomous agents are AI-powered systems that perform tasks independently. They assess situations and act without step-by-step guidance. The best practice here is, because of this independence, your guardrails must be rock solid. Define clear boundaries for what the agent can and cannot do. Establish escalation paths for edge cases and always include a human-in-the-loop checkpoint for high-stakes decisions. Autonomy without guardrails is a risk, not a feature. Autonomous agents share some components with task agents, but there are important additions. Goals still define what the agent should accomplish, but now we add triggers, which are events that start the agent automatically. Things like user input, system changes, or scheduled prompts. Instructions provide the business rules that guide behavior and decision-making. Knowledge sources give the agent access to documents, SharePoint, and Dataverse. And actions are the operations the agent performs. The big difference here is the trigger. Task agents typically respond to direct requests. Autonomous agents can activate themselves based on events happening in your environments. Designing an autonomous agent follows a 4-step workflow. Identify the use case, build in Copilot Studio, test thoroughly, and deploy to teams. Best practice is to spend the most time on step 3, testing. Autonomous agents amplify any design flaw because they operate independently. Test your business logic, edge cases, and failure modes repeatedly before putting any autonomous agents into production. This component summary is your autonomous agent design checklist. Goals, triggers, instructions, knowledge, actions, and publishing must all be clearly defined. The best practice, before you publish any autonomous agent, have a peer review of every component. A second pair of eyes catches assumptions and edge cases you might miss. Validation is part of the design process, not separate from it. Here are the best practices for autonomous agents specifically. Start with a simple high-value use case. Do not begin with your most complex workflow. Provide clean, structured instructions so the agent knows exactly how to behave. Limit your knowledge sources to improve accuracy. More is not always better. Use only approved and reviewed grounding sources to ensure reliability. Test your business logic repeatedly before publishing because once an autonomous agent is live, it acts on its own. And finally, monitor and refine based on real-world feedback. Autonomous agents need ongoing attention. Launch is the beginning, not the end. Let's dive into prompt and response agents. These are the conversational workhorses of Copilot Studio. Prompt and response agents combine several powerful capabilities. They use natural language understanding to process user prompts and identify intent. They use topic-based logic to match conversations to the right knowledge or workflow. And they use event-driven behavior to trigger actions based on what is happening in the system. The flow works like this. A user sends a prompt, the agent identifies intent and retrieves content from the knowledge sources or topics. Conditions shape the dialogue flow to determine the right response. And triggers can start actions based on events. This combination makes these agents highly flexible and adaptive. One of the most powerful features is the Generative Answers node. This allows your agent to answer questions directly from knowledge sources, including public websites, Dataverse, SharePoint, and even enterprise connectors. Here's why this matters. If your agent cannot match a user's question to a predefined topic, it does not just hit a dead end. Instead, it uses Generative Answers as a fallback, searching your knowledge sources to construct a relevant response. This dramatically reduces the number of topics you need to manually author, while still giving users accurate, grounded answers. It is a game changer for covering the long tail of user questions. Building on Generative Answers, there are conditional capabilities that make your responses more polished and functional. Agents can store generated responses in variables for reuse later in the conversation. They can surface information on adaptive cards, which provide rich, interactive formatting within channels like Teams. And they can apply custom formatting to tailor how information is presented to the user. These features let you go beyond plain text replies and create a more professional, structured experience. When designing your agent, think about how the response will look and feel to the end user, not just whether the content is correct. System topics are built-in capabilities that handle core conversational moments. These include greeting for when the conversation starts, escalation for handing off to a human, fallback for when the agent does not understand, end of conversation for wrapping up cleanly, disambiguation for clarifying ambiguous requests, and error handling for managing failures gracefully. These topics ensure consistency and predictable behavior across every interaction. Do not overlook them. Customizing system topics to match your organization's tone and policies is one of the easiest ways to improve the overall user experience with minimal efforts. Condition nodes let your agent branch its responses based on logic. You can use comparisons, variables, operators, and/or logic to create dynamic conversation paths. For example, you might check a customer's account type and route premium customers to one response while standard customers get another. Or you might evaluate for input to determine the next step. Condition nodes also support power effects formulas, giving you additional flexibility for complex evaluations. The key design principle is to keep your branching clear and manageable. Every branch you add is a path you need to test and maintain, so be intentional about complexity. Event triggers take your agent beyond just responding to user messages. They enable agents to act without any user prompt at all. For example, an agent could activate when a file is uploaded, a task is completed, a Dataverse row is added, or on a scheduled recurrence. This is powerful because it means your agent can proactively monitor and respond to changes in your environment. Two important notes. Event triggers must be explicitly authorized so there is governance checkpoint built in, and they may impact billing, so factor that into your planning. Use them strategically for high-value automation scenarios. This diagram shows how a prompt and response agent works as a complete system. Understanding how NLU, or natural language understanding, topics, conditions, and triggers work together is essential for troubleshooting. The best practice here, when a conversation goes wrong, use this architecture as your diagnostic framework. Was intent identified correctly? Did the right topic match? Did conditions evaluate properly? Systematic diagnoses using this model saves hours of debugging. Here's a helpful reference for choosing the right mechanism. Use generative answers when users ask questions not covered by your predefined topics. Use system topics for standard interactions like greetings, fallback, and escalation. Use condition nodes when you need to branch responses based on variable values or user context. And use event triggers when your agent needs to react to system events without waiting for user inputs. Each mechanism has its sweet spot. The best agent designs use all four in combination, creating a layered experience that handles both expected and unexpected interactions gracefully. Now we are entering a more technical session. We are going to look at how to propose the right Microsoft Foundry tools for a given requirement. Microsoft Foundry provides a catalog of tools for retrieving data, calling APIs, grounding responses, and orchestrating workflows. Your job is to select the correct tool with minimal complexity. You want to ensure security and compliance, leverage existing systems wherever possible, and reduce integration overheads. The key here is not to reach for the most powerful tool, but the most appropriate one. Over the next several slides, we will walk through the major tool categories so you can build a mental model for matching requirements to the right tools. The first category is retrieval and grounding tools. These are for accessing enterprise knowledge and making sure your agent's responses are grounding in accurate information. Key capabilities include vector search for semantic matching, hybrid search that combines keyword and vector approaches, indexing of both structured and unstructured sources, and querying knowledge bases. When your requirement involves finding and surfacing information from documents, policies, or knowledge bases, retrieval and grounding tools are your starting points. They are fundamental to building agents that give trustworthy and fact-based answers, rather than generating unsupported responses. Data and application connectors are for interacting with your business applications and databases. This includes CRM systems, ERP platforms, financial systems, line of business applications, and more. When your requirement involves reading or writing to an existing business system, these connectors are what you need. The advantage of using established connectors rather than building custom integrations from scratch is reliability, security, and reduced maintenance. Always check whether a native connector exists before building something custom. It will save you time and reduce the support burden. Workflow and action tools are for triggering automated actions. Think creating records, updating cases, sending notifications, triggering Power Automate flows, or calling custom APIs. These tools are essential when your agent needs to do something, not just retrieve information. The distinction matters because retrieving data and taking action require different levels of governance and testing. Actions change state in your systems, so they demand more careful validation and error handling. When designing with workload tools, always consider what happens if the action fails and build the appropriate recovery paths. Reasoning, planning, and execution tools handle the thinking side of your agent's architecture. These tools evaluate conditions, break complex tasks into manageable steps, select the right action from multiple options, and handle branching logic. When your requirement involves multi-step decision making, or the agent needs to choose between different paths based on context, these are the tools you reach for. They are especially important for autonomous agents that need to figure out the next best step without human guidance. Pair them with strong safety rules to ensure the reasoning stays within acceptable boundaries. Finally, there are specialized tools for specific processing needs. These include document summarization for condensing long contents, classification for categorizing inputs, custom machine learning model execution for running your own trained models, and safe completion and validation for ensuring outputs meet the quality standards you set. These tools are not used in every agent design, but when you need them, they are invaluable. The key is knowing they exist so you can propose them when requirements call for specialized processing. Do not try to force general-purpose tools to handle tasks the specialized tools are built for. Let's apply this to a real scenario. Say your requirement is to retrieve policies and guidelines for your agent to reference. The recommended tools are retrieval tools with vector search for semantic matching, hybrid search connectors for combining keyword and semantic approaches, and SharePoint or OneDrive ingestion for pulling in your existing document libraries. This combination grounds your agent in enterprise knowledge while maintaining security controls. The important design principle here is that your agent should never make things up. Grounding it in actual organizational documents ensures accuracy and builds user trust. Now imagine your requirement is to integrate with business systems like Dynamics, SAP, or ServiceNow. The recommended approach starts with native application connectors when they are available, because they are pre-built, tested, and maintained. For systems without native connectors, use custom REST or Graph API connectors. These tools let your agent read and write data in enterprise systems securely. The key architectural decision is whether you need read-only access or read-writes. Start with the minimum access required and expand only when the business case justifies it. This follows the principle of least privilege. When your requirement involves executing multi-step workflows, reach for the Power Automate Flow connector, workflow orchestration tools, and custom action tools. These let your agent trigger actions reliably and repeatably. For example, an agent might need to look up a customer, create a case, assign it to the right team, and send a confirmation. That is a multi-step workflow that needs to execute consistently every time. The orchestration tools ensure steps happen in the right order with proper error handling at each stage. Reliability is the primary concern here. If a workflow fails halfway through, you need to handle that gracefully. For requirements involving data analysis or transformation, the recommended tools are Azure Functions for custom compute, machine learning model tools for applying trained models, and data transformation connectors for structured processing. These tools handle the work of processing data before returning results to the user. For example, you might need to aggregate sales figures, apply a scoring model, or reformat data from one system to match another. The key principle is to do the heavy processing outside the conversation flow and return clean, ready-to-use results. This keeps your agent responsive and your architecture clean. When your requirement involves advanced reasoning, you need planner and reasoning tools, LLM-based decision tools, and context evaluators. These help your agents choose the right next step safely. Advanced reasoning is critical when the agent faces ambiguous inputs or needs to weigh multiple factors before acting. For example, an agent might need to evaluate whether a customer request requires standard processing, expedited handling, or escalation to a specialist. The reasoning tools help the agent make that judgment. Always pair advanced reasoning with clear constraints and human oversight for high-stakes decision. This table gives you a quick reference for mapping requirements to Foundry tool categories. document retrieval, maps to retrieval and grounding tools, application integration, maps to app and data connectors, workflow automation, maps to workflow and action tools, data processing maps to compute tools, and decision-making or planning maps to reasoning tools. Keep this mapping in mind as you design. Most real-world agent solutions will combine tools from multiple categories. The skill is knowing which combination addresses your specific requirements with the least complexity while maintaining security and reliability. Let's recap what we've learned. You can now apply responsible AI principles to AI agent design, ensuring your agents are fair, transparent, and accountable. You know how to configure business terms and customize Copilot in Dynamics 365. You understand how to design custom connectors and integrate AI agents with Dynamics 365 Contact Center. And you have learned how to build task-focused and autonomous agents using Copilot Studio. That is a strong foundation. In Part 2, we will build on this by going deeper into the implementation. We've covered a lot in this session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching. Now you are ready to start building systems where intelligent agents collaborate and deliver.